Hey there, folks. Welcome back to the fifth episode in this Web Dev Basics tutorial series. Last episode, we started talking about JavaScript, some various data types, and basic operators. Today, we're going to continue with JavaScript and talk about if statements and logical operators. So let's just dive right into it. So with JavaScript, we can write our code so that if a condition is met, it will execute a specific block of code, and if that condition is not met, it will either execute a different block of code or do nothing at all. For example, let's look at a simple if statement using the age variable that we set last episode. So we start with the keyword if, followed by some parentheses and then curly brackets. Inside of these parentheses, we have an expression. In this case, we're checking if the age variable is less than 13. And if the expression evaluates to true, the code executes what's inside of the curly brackets. If it's false, we'll skip that segment entirely. So when we run it, well, nothing happens, or at least nothing is logged to the console. If age is 31, then it's not less than 13, so the expression evaluates to false. If we were to change this to 12, now we can see that the word child is printed to the console. We could have the code do something else if the expression is false by using the else keyword after the curly brackets. And then if we set age back to something that's above 13, now we see that the word teenager is written to the console. However, it would still say teenager if we were to set age back to 31, which is certainly not a teenager. So to fix this, we can just chain on another if statement after the else. And then we can add another else after here for adult. So the code first checks if age is less than 13, and if it is, log child. If not, then check if age is less than 20. If it is, log teenager. And if not, log adult. And that looks to be working. So if statements are great when you want to check if a variable falls into a range of conditions like we're doing here. However, if you have a variable and you want to do different things depending on exactly what the value is, an if statement could work for this, but it might end up getting a bit repetitive. Instead, we could use a switch statement. A switch statement lets us take one value and compare it to a bunch of possible options and run different code for each one. So for example, let's say we have a variable called day, and I'll set this to the string Monday. We can use a switch statement to execute a certain block of code depending on the value of this day variable, which we know would only have one of 7 distinct values. So I'll just write this one out and then we'll talk through it. Okay, so let's start from the top. This starts just like an if statement where we use the switch keyword followed by a set of parentheses and then curly brackets. In the parentheses, we have the variable we want to check, day. Inside the curly brackets, the first line we come across has the case keyword followed by the string Monday and a colon. And on the next line below that, we have a console log with the message start of the week and then this keyword break. So if the day variable meets the condition of this case and equals the string Monday, we'll execute the block of code that comes after the colon. We can see this in action and yep, it console logs start of the week. But what's this break for? Why are we breaking our code? Well, this keyword tells JavaScript that we're done here. There's no need to continue looking at this switch statement. We've got what we need out of it. If we were to remove the break and then run the code again, we see the message start of the week, but we also see the message almost the weekend. But day is Monday, and this executed the code under the Friday case. This is where switch statements can really differ from if statements. Everything inside of these curly brackets is the code that we're going to execute. The case statements just determine where to start. So once a case statement is met, it will execute every line of code until it finds a break or return keyword or it reaches the end of the switch. So that's why we need to use these break keywords. And this is also why we don't need any code directly after the Saturday case, and we can simply pair it up with the Sunday case. And for both cases, it will just log it's the weekend and then break from the switch. Finally, towards the bottom, we have the default keyword, which is where the code will start if no other case statements are met. This is essentially the else when not followed by another if. With the default, we don't need to add specific cases for Tuesday, Wednesday, and Thursday. In this example, we could do the same exact thing using an if statement, and I'll put a comparison of the two on the screen. These blocks of code accomplish the same exact thing, it's simply just two different ways to do it. If you're like me, you might think the switch statement looks a little cleaner and is easier to read, despite it using more lines, but either one gets the job done. Whatever method you choose to use is ultimately up to you. So let's shift back to our if statements and talk a little bit more about the expressions we have in these parentheses. In this example, we have a single expression which uses a comparison operator to compare the variable age to a certain number. This expression returns a Boolean, true or false. However, we could also use multiple expressions to chain them together using logical operators. These logical operators are and, or, and not, which are represented with a double ampersand for and, a double pipe for or, and a bang for not. These allow us to check multiple conditions before executing some code. So, for example, when you log into a website, the code is checking if the username you entered exists and that the password you entered matches. If both are true, then you're logged in. If either one is false, then you'll probably get an error message saying incorrect username or password. Now, that very same code might also first check to see if the username field is empty or if the password field is empty. And if either of those are true, then it might give the message, please fill out all required fields. So let's see a bit more of this in action. So to start, I'll just write out a pretty simple if statement that we can use for testing. And then let's add a couple new Boolean values. So with and, both values on either the left or right side of the and operator must be true for the entire expression to be true. If either one is false, then the entire expression is false. So if we have bool1, double ampersand, bool2, and we see the expression is false. And that's because bool1 is true, but bool2 is false. So bool1 and bool2 is false. But with or, only one side of the expression needs to be true for the entire expression to be true. It would only be false if both values on either side of the operator are false. Now we see that the expression is true because bool1 is true. And then with the not operator, we are simply flipping the value. So bool1 is true, but not bool1 is false. So now not bool1 is false and bool2 is also false. So this expression just boils down to false or false, which evaluates to false. Now, let's add a bit more complexity to the expression and introduce the third Boolean, bool3. So we'll add and bool3, and then we'll just get rid of the not, make this a little bit less confusing. So now we have bool1 or bool2 and bool3. And when we run it, we see that this evaluates to true. With these more complex expressions, JavaScript will evaluate ands before the ors. Because of that, the code first evaluates the sub-expression bool2 and bool3. Since both bool2 and bool3 are false, and an and expression requires both sides to be true, this sub-expression evaluates to false. And that leaves us with bool1 or false. Bool1 is true, and because an or expression only needs one side to be true, the entire expression evaluates to true. Now, if you've ever heard of PEMDAS in algebra class, this next part may sound familiar to you, but we can surround certain parts of the expression in parentheses to have those parts evaluated first before anything outside of the parentheses. So we can add a set of parentheses around bool1 or bool2. And now, when we run the code, the expression is false. We've effectively changed the outcome. We're forcing the code to evaluate bool1 or bool2 first. And because bool1 is true, this sub-expression is true, which leaves us with true and bool3, or true and false, which comes out to false. Now, the last thing that I want to touch on for this topic are truthy and falsy values. As I mentioned in the last episode, JavaScript will sometimes use implicit type coercion to change the data type of a value on its own. We looked at examples of strings being converted into numbers and vice versa, but JavaScript can also convert values into booleans. The implied boolean value that a piece of data has is what we refer to as truthy or falsy. If a value would be converted to the boolean true, it's considered truthy, and if it would be converted to false, it's considered falsy. Now, with JavaScript, there are actually only 8 specific values that are falsy, and they are false, 0, -0, 0n, which is just 0 in a data type known as bigint, which is used for very large numbers, an empty string, so that's a pair of quotes with nothing in them, null, undefined, and NaN, not a number. So we'll just call these 3 0 for the sake of simplicity. And anything that is not on this list is truthy. So that includes any number, positive or negative, and any non-empty string, even if it's just white space characters. So we can replace this entire expression here with just null, and the code confirms that this is false. Now, what about the string 0? Well, that's truthy. It's a non-empty string. We could also throw in the email variable that we declared last episode but never defined. And that comes out to be falsy because it's undefined. This can be pretty handy for checking whether a variable has a value or not. You can just drop the variable directly into an if statement like we did with email here. And if it's truthy, that means it has some usable value that we can safely do something with. And if it's falsy, then maybe it's null or undefined, and we can either handle that case differently or do nothing at all. Using checks like this can help to prevent your code from throwing errors when you try to use a variable that doesn't exist. All right, folks, that's going to do it for this episode. In the next one, we're going to be writing some loops and functions so that we can repeat tasks without having to repeat lines of code. As always, thank you so very much for checking out this video. Please consider leaving a like or subscribing if you want to show me a bit of support. I really do appreciate it. And I will see you in the next one.